So the next type of question we have here is all about acceleration. Okay, we have some standard problems to calculate the acceleration. This question here is saying find the acceleration, determine his acceleration. So all these questions require the same formula. If we look at the formula triangle for acceleration, we have acceleration in the bottom, call it A, times time, and at the top we have speed. Let's say the final speed minus the initial speed. Because remember, acceleration is a change of speed. So we need two speeds to see how much it changes by, divided by the time to know how quickly it changes speed. Because acceleration actually is how quickly something changes speed. So let's just make a note here. Time, change of speed. So we have speed initial. This means the speed it starts at. And then we have the final speed, the speed it ends at, and of course we have the acceleration. Just make a note of the units that they're measured in. Time is measured in seconds, so we for example have 1 second. Initial speed and final speed are both measured in meters per second, so we would have 1 meter per second. And acceleration is measured in meters per second squared. So there's a 2. This will help you to find which numbers from the question are needed and where they go in the formula. So, let's have a look at the first question. During a race, a sprinter increases his velocity from -5 to -9 meters per second over a period of 2 seconds. Calculate the acceleration. So we have here 2 seconds, -5 meters per second, and -9 meters per second. 3 numbers. So what do these numbers mean? Well, if we remember what each of the units represent, seconds, meters per second, we will actually know what these numbers are telling us. Seconds refer to time. So we can put here the first one, 2 seconds, is to do with time. Meter per second is not acceleration, that's meters per second squared. It's to do with speed. So meter per second. So we can put here the symbol S. If you use the symbol V for velocity, that's also fine. But for simplicity, I'm going to use S. So this is S, and this is also S because it's meters per second. Of course, one of them's the starting speed, one of them's the finishing speed. So in the question it says it went from -5 to -9. So I'm going to say this one's the starting speed, the initial speed, and this one's the final speed. Okay? Now, it wants us to find the acceleration, A. So what is A equal to? Well, we've got to go to our triangle again. A equals, if we cover up the A, we can find out what it equals. SF minus SI divided by T. A equals SF minus SI divided by T. Okay? Because you must cover up the one you want to find, and whatever you're left with is what the formula is. So A is what we want to find, equals what's left, SF minus SI divided by T. And that's what we've written. A equals SF minus SI divided by T. Now it's a simple matter of putting the correct numbers in. So we've said that SF is -9. So let's put that in, -9. Then we've got a minus here, so we've got to keep that a minus. And then in here we've got SI, minus 5, divided by T. T is 2. So now we've left with minus 9 minus minus 5 divided by 2. So this is minus 9 minus minus 5 becomes a plus, minus and a minus becomes a plus, divided by 2. So now we have minus 9 plus 5. You look at your number scales, minus 9 plus 5, well you can use a calculator. Minus 9, you add 5, would be minus 4. Divided by 2, that's the same as saying minus, you cancel down, minus 2 is the answer. Let's have a look at question part D. A cyclist accelerates from rest to minus 8 in 4 seconds. Determine his acceleration. They've given us two numbers, minus 8 meters per second and 4 seconds. Meters per second, again, we know is an S, speed. 4 seconds we know is a time. And we need to find acceleration. So, our formula, if we remember from before, A equals SF minus SI divided by T. So, A equals speed final minus speed initial divided by time. Now we can put in the numbers. We have speed and time. So we know the time is definitely 4 seconds. But what about the speed? We need 2 and we've only got 1, and we don't know which one this is. Is it final or initial? In the question it actually says from rest to minus 8 meters per second. So rest here, although it's in words, is actually talking about a speed. So we know rest here is talking about speed. What speed in number could rest be? 0, because it's not moving, it's resting. So now we have two speeds, 0 and minus 8. The initial, the start speed is from rest to minus 8. By the way, if you want to know which one's initial and final, usually the words from goes before speed initial, and the word to goes before speed final. So now we have your two numbers. Speed final is minus 8, so let's put that in. Minus speed initial is 0, and we can put in the final answer. Minus 8 minus 0 is minus 8, divided by 4 is 4. This cancels down to minus 2. By the way, we forgot to put in the units before, so let's put it in now. The units for acceleration are m, s, 2. Don't forget the 2. Over here we should have put the answer as minus 2, m, s, 2. Have a go and see if you can solve this one. Find the uniform acceleration, so you're finding the acceleration, that would cause a car's velocity to change from 32 to 14 in 6 seconds. Did you get it right? They gave you three numbers: 32 meters per second, speed initial; 14 meters per second, speed final; time 6 seconds. They wanted the acceleration, so you did the formula, put in the numbers, simplified, and you should have got 3 meters per second squared. Well done if you got it right.